Pagi hari ini saya akan menyampaikan video tutorial tentang microcontraction. Mohon diperhatikan dengan sesama karena nanti ada pertanyaan yang terkait dengan video tersebut. Silakan.
Please visit Facebook and Instagram. Please like, and here you can also ask questions, answer questions, and please post some interesting things, including artworks. And you can also change the quality settings to the highest one for better graphics. And in this video, we're going to talk about skeletal muscle contraction. And so with this, we begin with a neuron, a nerve cell. And this neuron is specifically what's called a somatic neuron. And here we have a muscle fiber from a muscle. And so a skeletal muscle will contract only when stimulated by a somatic motor neuron. And so if we have a signal here that comes towards a neuron, this can cause the muscle fiber to contract. Now, a somatic motor neuron can innervate between 3 to up to 1,000 muscle fibers.
Oke, adik-adik mahasiswa, di sini dikatakan bahwa setiap somatic sel neuron itu bisa menginervasi dari antara 3 sampai 1000 muscle fiber. Nah, di sini mungkin di kuliah berikutnya juga kita akan lebih rinci mengatakan bahwa kekuatan otot tidak semata-mata diukur dari berapa besarnya massa otot tersebut, tapi adalah seberapa banyak setiap saraf yang bisa menginervasi muscle fiber.
And so when a neuron, the neuron's nerve fibers, connects to a muscle fiber, this complex is what we call a motor unit. So it's where we have a nerve fiber and a muscle fiber. So if you remember what a muscle fiber is, if we have a bone here with a muscle attaching on it, we have the tendon which attaches to the bone, and here we have the actual muscle. Now the muscle contains many structures within it, portions of the muscle known as fascicles, and these fascicles then contain many muscle fibers. And so here is where our muscle fiber is. So now let's zoom into one motor unit here and see what kind of structures are around in the muscle fiber and also the end of this neuron that assists in muscle contraction. And so here we have the end ball, the axon terminal of the motor neuron. And the axon terminal of the motor neuron, the end ball, has many vesicles here. And these vesicles contain neurotransmitters known as acetylcholine. So now we'll just stop there for now and look at the muscle fibers. And so here we have the muscle fiber, one muscle fiber, and the muscle fiber contains many myofibrils. So here we have the myofibrils. And around this area, within the muscle fiber, we have also mitochondria, which can provide ATP. And we also have many nucleus around the muscle fiber, because the muscle fiber is multinucleated. The muscle fiber has a membrane called the sarcolemma, which contains many receptors and ion channels. Now let's stop there for a bit and look specifically at the myofibrils. So if you remember, the myofibrils contain thin and thick filaments. Here in blue is the thin filaments and in red the thick filaments. From one Z line to another Z line of the thin filaments is what we call a sarcomere. And so we have this within each myofibril. However, in each myofibril, you can say, we also have what's called the T-tubule, which runs around the myofibril. And the T-tubule, surrounding it, we have what's called the sarcoplasmic reticulum, abbreviated SR. And these sarcoplasmic reticulum contain calcium ions. Let's have a closer look at the T-tubule, because the T-tubule has an important role in skeletal muscle contraction. The T-tubule essentially connects with the outer membrane and wraps around the myofibril. And the T-tubule contains special ion channels for calcium, here shown in orange. Surrounding the T-tubule, we have the sarcoplasmic reticulum, which contains calcium ions. So surrounding it here, we have the sarcoplasmic reticulum. Specifically, what's called the terminal cisternae, which is part of the sarcoplasmic reticulum. And the terminal cisternae contains these calcium ions. But these calcium ions, they cannot go into the T tubule because the ion channels, the calcium ion channels, are blocked. And therefore they need to be opened for calcium to come out. And here, of course, beneath this T tubule, or within the myofiber, we have the thin filaments and thick filaments. And the thin filaments requires calcium in order to initiate muscle contraction. But remember, the calciums are still within the sacroplasmic reticulum. So how do these calcium ions come out? Well, let's have a look. Let's begin at the neuron. The neuron's end bulb, the axon terminal, where action potential has arrived. This action potential will cause these vesicles containing acetylcholine to release acetylcholine out. These acetylcholine will then bind onto the receptors in the sacrolemma. Let's have a closer look.
Jadi dari penjelasan tadi kita lihat bahwa perintah atau dari susunan saraf somatik untuk mengkontraksikan otot dimulai dari akson terminal, di mana di akson terminal akan merilis dari neurotransmitter yang bernama acetylcholine. Beberapa obat bahkan racun pada zaman dulu yang digunakan untuk melumpuhkan kontraksi otot, salah satunya adalah memblok rilisnya dari acetylcholine, sehingga dengan tidak adanya rilisnya acetylcholine, tidak ada rangsangan dari sistem saraf untuk mengkontraksikan otot.
Look at this interaction between acetylcholine and the receptors in the sacrolemma. So here we have the end bulb, the axon terminal of the motor neuron, and here we have a vesicle containing acetylcholine. Here is our receptor for acetylcholine on the sacrolemma. And a point to make, which is pretty important, is outside in the extracellular fluid, we have high concentrations of sodium, and within the muscle, within the sacrolemma, inside the cell, we have high concentrations of potassium ions. So what happens is, when the vesicle containing acetylcholine releases acetylcholine out, these acetylcholines will then bind onto this receptor, which will cause the receptor to open. When this receptor opens, sodium ions can then come inside. And when sodium comes inside, this will open the voltage-gated channels, which will then create an action potential. These action potentials will then travel across the sacrolemma, where the action potential can then propagate down the T tubule. When the action potential travels down the T tubule, it will cause these calcium ion channels, which were previously closed, to open up. And it opens up because there's a change in voltage in the T tubule, which will cause the calcium channels to open. And so when these calcium channels open, calcium will then move out from the terminal cistern into the T tubule. Will travel down and essentially go and bind onto the thin filaments. And so essentially, calcium and also ATP will help with muscle contraction. And to understand how they help in muscle contraction, please click on the link for the sliding filament theory, which will look at the contraction at a molecular level, at a sarcomere level.
Ya, jadi di video ini dijelaskan dari mulainya rangsangan pada saraf-saraf somatik sampai pelepasan neurotransmitter acetylcholine sehingga merangsang terjadinya potensial aksi, terutama di T tubulus, sampai terjadi pelepasan ion Ca. Untuk video berikutnya akan kami jelaskan tentang bagaimana ion kalsium tadi menginisiasi terjadinya muscle contraction. Terima kasih.